name is Michael Campanovo, and I'm the Outreach Coordinator for the Geography Department here at the University of Tennessee. And we've been using augmented reality in our classrooms and for our outreach activities for the last about a year and a half. We initially started using augmented reality with an AR Sandbox for our terrain analysis class as well as our remote sensing classes. For the terrain analysis class, students are learning how to conceptualize a 2D model in 3 dimensions. So they're learning all about contour lines, topography, and landforms. And instead of having to learn about that in a static 2-dimensional contour map, they're actually able to manipulate our augmented reality sandbox and build those terrains in 3D. This is a very hands-on and engaging way for our students to learn how topography and landforms have an impact on the movement of water through a region or an ecosystem. It's also a great way for students to visualize how the water cycle works and the concept of watersheds and how water moves throughout a system. So in addition to classroom use, we're also using the augmented reality sandbox for outreach for K-12 communities as well as here on campus. And what we're finding is that most students find that the sandbox is a way more fun and engaging and effective tool for learning about the things that they're already learning about in classrooms. So when we work with schools and we set up for the K-12 classroom, oftentimes we'll set the sandbox up with the lid actually on top so the students don't see the sand in the interactive part to start with. What we actually do is display the image on the cover so it actually looks like a flat topographic map. And we sort of start this process of having the students hypothesize on what it is that they think they're seeing. Talk a lot about what kind of maps there are, what they see on maps, what they use maps for, and then we start to tease out what the students' own experiences are and how those relate to maps. And so how do they know where to look to find water? So they always know that water flows downhill. So once we know that on the map that water is blue and it represents the low points on the map, then we can start to hypothesize about what that means in terms of elevation and topography for the other features on the map. We can even talk to them, especially in East Tennessee, about what happens in the winter on top of mountains, because they can often see the white on top of the model, and then they can relate that to snow that they see in the mountains over the winter. So then we have our high points and our low points, and we can start to figure out what the contour lines represent and how they represent changes in topography, steep areas and low areas as well. The newest piece of augmented reality equipment that we've recently acquired is a SimTable developed by a team out of Santa Fe, New Mexico. And this actually uses real geospatial data to represent models for natural hazards and disasters on top of a SimTable or a sandbox. So in this case we're using real geospatial data to provide the inputs for the models, and then we use agent-based modeling to show how those models actually play out in real time. All the modeling is actually done in the software itself, as opposed to the augmented reality sandbox, which does all the modeling in real time based off of the terrain in the sandbox. So one of the differences between how students interact with the augmented reality sandbox as opposed to the SimTable is that the SimTable loads a real digital elevation model, and when the students interact with the material, they're actually mimicking the real terrain, as opposed to the augmented reality sandbox, where the system is actually scanning what the students build in real time. So it's creating the terrain, the contour lines based off of what the students create. So in addition to the initial remote sensing class and the initial terrain analysis class, we've actually been able to incorporate this technology across the curriculum here in the geography department. Dr. Melissa Hinton teaches a class on national parks, and she has a whole unit that she does on the impacts of wildfire on the national parks. So we've been able to incorporate the SimTable and have the students research different fires and then simulate those fires in the SimTable so they can get a better understanding of the impacts that the fires have on the landscape, the terrain, and the people that use those national parks. We're also working with Dr. Liam Tran's class on GIS modeling, and the students there are learning how to write agent-based modeling that will be used inside the SimTable. Dr. Kim's class is a transportation course, and we're going to be using the SimTable's evacuation routing procedures and models to show the impacts of closing different intersections in a transportation network and what sort of impact that has to traffic. And then outside of UT, we're also using the SimTable at Vine Middle Magnet School as part of their after-school Great Schools Partnership Program. And the students there have spent the spring semester learning how to model wildfire, the impact that fuel density and fuel type has on wildfire, and they'll actually be developing their own fire scenarios and then actually recording like a news report about the different fires that they're building and showing people how they're using different firefighting tools and techniques to actually fight those fires.